welcome to this pre-recorded presentation for the third public information meeting of the Braddock Road Multimodal Improvements Project. My name is Andy Beecher, and I am Assistant Director for Transportation and Land Use with VDOT. Next slide, please. Here is our agenda for tonight. We'll start by introducing the project team, review the project location and background, and provide an overview of the project. And then for the bulk of the presentation, we will address key topics that have been brought up during our previous public information and community association meetings, including use of the existing trail, tree preservation, stormwater management, the pedestrian bridge, Ravensworth Road, and the critical intersection evaluation methodology. We'll conclude the presentation by providing an update on project cost, funding, and schedule. Next slide, please. Key staff on the project team include myself, Andrew Beecher, Assistant Transportation and Land Use Director. Calvin Britt is the VDOT Project Manager for this effort. Tad Borkowski is Senior Transportation Planner with Fairfax County DOT. Phil Lohr is VDOT's Consultant Project Manager, and Suresh Khare is VDOT's Consultant Traffic Lead. I also want to introduce Minwoo Ha, who is taking over as Preliminary Engineering Manager for this project as I transition to my new role. Next slide, please. Once again, the location of this project is on Braddock Road between approximately Humphreys Drive to the west and Ravensworth Road up to Heritage Drive to the east, shown in the light and dark blue colors. The yellow circles represent the critical intersections where various alternative design options were considered in order to determine a preferred alternative. And as we have explained previously, the current effort, administered by VDOT on behalf of Fairfax County, will develop plans for the entirety of these limits up through the project's public hearing and design approval, with design approval being the approval of a project's major design elements. After design approval, the project has been split into two phases for implementation. For phase one, which is from Southampton Drive to Ravensworth Road, shown in dark blue, Fairfax County applied for and received funding through construction via the Commonwealth Smart Scale program. Phase two, which is from approximately Humphreys Drive to Southampton Drive, shown in light blue, is currently not funded beyond design approval. However, VDOT and Fairfax County will continue to work together to identify full funding opportunities for this phase. And now I'd like to turn the presentation over to Tad Borkowski from Fairfax County, who led the previous county study and will once again share background information about the project. Tad?
Thank you, Andy. The Braddock Road multimodal study was undertaken by the Fairfax County Department of Transportation to evaluate a potential widening of Braddock Road as indicated in the county's comprehensive plan. Various options were considered, focusing on context-sensitive design and multimodal improvements to address the pervasive traffic congestion, improve transit access, and improve bicycle and pedestrian access and safety along the corridor. After extensive community and stakeholder coordination, working closely with the community task force, the preferred conceptual design was selected, consisting of multimodal corridor and intersection improvements rather than widening the road. The County Board of Supervisors endorsed the preferred conceptual design on November 27, 2017. After several unsuccessful attempts at securing funding, the project was split into two phases to increase chances of securing some funding to advance the project. In 2020, the part of VDOT pilot project proposed changes were included with the phase one smart scale application to reduce costs. Those proposed changes were presented to the community on August 3rd, 2020. Later in 2020, Fairfax County and VDOT coordinated on the best implementation approach, and VDOT agreed to take on development of the project on behalf of the county. In May 2021, as Andy said, this approach was successful and smart scale funding was awarded to phase one. The county continues to seek funding for phase two partnership with VDOT. And now I would turn the presentation over to VDOT project manager, Calvin Britt.
Thank you, Tad. When looking at the future no-bill conditions for the corridor in 2045, it is projected to have a 30% increase in average intersection delay and a 20% increase in travel times throughout the corridor when compared to the existing condition. This increased congestion may lead to decreased safety for pedestrians and cyclists, as well as reduced transit reliability without the project being constructed. Next slide, please. VDOT is excited to be here to continue the development of the design for the Braddock Road Multimodal Improvement Project. Our work builds on the county work with a focus on implementing multimodal improvements along the Braddock Road corridor. VDOT has continued to collaborate with the county throughout the design process, and all the information, designs, and analysis that will be shared with you tonight were developed with these 5 overarching project goals. Number 1, improving connections and access on both sides of Braddock Road. 2, improving the comfort and safety and facility for bicycles and pedestrians throughout the corridor. 3, improving transit accessibility. 4, maintaining and improving vehicle travel times throughout the corridor. And number 5, improving safety for vehicles by implementing access management at select intersections. Next slide, please. Typical section between intersections. While there are design adjustments at specific locations, the project's typical cross-section include a new bi-directional 10-foot shared use path, offset 10 foot from the edge of the travel lane with 8-foot buffer between the shared use path and the face of curve, and a 2-foot gutter path on each side of Braddock Road, and the retention of the existing 3 vehicle lanes in each direction. This is in line with the recommendation resulting from the county study that Tab described. Other design features include no roadway widening outside of the critical intersections, consolidated bus stops and improved accessibility to these stops, access management improvement that ensure sufficient spacing between intersections and entrances, improving the traffic flow and increase safety, intersection improvement throughout the corridor to enhance safety and operations through these intersections for all modes of traffic. And now I would turn the presentation over to Phil Law, our consultant team, to go over some of the key design issues that we have been working since November the 29th public information meeting.
Thanks, Calvin. One of the questions that has come up in multiple public forums is, why is a new shared use path needed in the sections where there is already a trail that runs parallel to Braddock Road? In response to this question, the project team reviewed the entire Braddock Road corridor to determine if there are portions of the existing trails that are viable to retain. Sections of the existing trail have significant challenges that make them unsuitable for use as a shared use path. As you can see in the photo from our site visit on February 8th, 2023, the existing trails are roughly 6 feet wide. This is sufficient for pedestrians to pass, but insufficient for bicyclists and wheelchair users to comfortably pass. There are many areas with steep grades, often exceeding 10%. To be compliant with the Americans with Disabilities Act, or ADA, which is federal law, the grades need to be limited to 5%. To achieve these flat grades, the existing trails would have to be reconstructed. Some sections of the existing trail are set far back from the roadway and have limited visibility to the public, which may feel uncomfortable for some users. The proposed shared use path addresses key issues with the existing trails. The path will be 10 feet wide, which is ample for all users to comfortably pass one another. Grades will meet the ADA requirements by providing a facility that is usable by everyone, including those with disabilities. Providing conduit for future pedestrian lighting to be added by the county and an 8-foot buffer from the face of curb will provide good visibility and a comfortable facility for both recreational users and commuters as the county continues to expand its network of bicycle and pedestrian amenities. Slide, please. So the results of our study are as follows. In the areas where the trail grades are under 5% and the trails are close to Braddock Road, it will be possible to widen or reconstruct them and incorporate them into the shared use paths. However, it will not be possible to preserve all the trees in those areas. These sections constitute approximately 27% of the existing trails. Approximately 35% of the existing trails are considered to be offset too far, varying from 40 to 75 feet from Braddock Road to function as shared use paths. The remaining 38% of the existing trails have grades that are too steep to be usable as shared use paths. Next slide, please. And speaking of trees, we have gone through a process of evaluating strategies to preserve more of them, as this has been a concern we have heard expressed repeatedly by the public. There are 4 strategies we have considered, namely consolidating stormwater management, or SWM facilities, adding retaining walls at select locations, providing new or replacement landscaping, and reducing the buffer strip and/or shared use path width at select locations. In just a minute, I will go into more detail on the first 2 strategies as they have proven to do the most for preserving trees. Regarding the latter 2 strategies, once the project footprint is firmed up, we will evaluate the placement of new landscaping. We recognize that young trees take time to grow and establish themselves, but new plantings of local flora may benefit the project over the long term. Any street trees planted adjacent to Braddock Road would need to be types that remain relatively small so as not to create a fixed object hazard for path users or motorists. Reducing the width of the buffer strip between the road and the path, or reducing the width of the path itself, only reduces the project footprint by approximately 4 feet at most. Reducing these widths would reduce the comfort for path users by pushing them closer to vehicular traffic and closer to one another when passing on the path, while providing negligible benefits in terms of tree preservation. Next slide, please. The topics we have explored in depth is how best to meet the project's stormwater management requirements. These requirements are described in the Code of Virginia, and compliance with the regulations is overseen by the Virginia Department of Environmental Quality. The county, VDOT, and the design team have collaborated on a revised SWM strategy that consolidates many of the linear best management practices, or BMPs, that is, stormwater management treatment facilities, shown previously into 10 facilities in lieu of the 21 presented in the earlier design. Using fewer, albeit larger, facilities will meet the state regulations, preserve more trees, and not burden VDOT with expensive long-term maintenance obligations. This graphic illustrates one location where we were able to implement this strategy. Next slide, please. The strategy we have explored is the use of retaining walls to preserve more trees, especially in residential areas, where approximately 75% of the walls are proposed. Some areas along Braddock Road require significant amounts of cut in order to construct the shared use path adjacent to the road, while in other areas the adjacent ground is lower than the road and requires substantial fill to accommodate the path. Walls add cost to the project, but at locations such as the one shown here, adding a retaining wall saves approximately 15 feet of impacts going up the slope away from the road. We have identified 9 locations totaling 2,900 linear feet where it will be worthwhile to include cut section retaining walls in order to preserve more trees. Mechanically stabilized earth, abbreviated as MSE, retaining walls tend to be the lowest cost to construct. But the key feature of MSE walls are straps that extend behind the face of the wall to provide the structural integrity. This requires substantial excavation behind a cut section wall, and so MSE walls are not suitable here where the goal is to preserve trees. There are other construction methods that can be used to minimize the impacts behind a retaining wall. These include the following: pile and lagging. In this type of wall, H-piles are drilled or driven into the ground, and then lagging, or panels, are placed between adjacent piles. Soil nail or soil screw walls. In this type of wall, construction proceeds from the top down in approximately 3-foot lifts. After a section is excavated, large nails are drilled and grouted, or large screws are screwed into the soil behind the wall, and then facing is attached to the nails or screws. The process is repeated until the desired wall height is achieved. Permanent sheet piles. In this type of wall, steel sheet piles are driven and left in place to function as the permanent wall, and then excavation proceeds in front of the wall. A full geotechnical investigation will be needed to determine the soil properties and presence and depth of rock before the appropriate type of wall can be designed at each location. Slide, please. This is an example of a location between Inverchapel Road and Queensberry Avenue where we have determined that adding a fill section retaining wall will help us preserve more trees. In this case, the wall will save approximately 20 feet of impacts going down the slope away from the road. Along the length of the corridor, we have identified 4 locations totaling 1,200 linear feet where it will be useful to include similar fill section retaining walls in order to preserve more trees. For the fill section walls, MSE walls may be viable, but again, the type of wall will be designed once the geotechnical investigation is complete. Slide, please. So here we are showing the overall benefits accrued by consolidating stormwater management facilities and adding retaining walls. Within existing VDOT right-of-way, tree preservation is increased by almost 70%, that is, from 28 to 47%. Where right-of-way or easement acquisition is necessary, the additional property is almost entirely needed to accommodate project grading, which means that within the limits of disturbance, the percentage of tree removal is a little higher. But even from this perspective, tree preservation is improved by about 70%. That is, from 24 to 41%. The percentages shown here are for both phases of the project. The example at the bottom of the slide would be part of phase 1. On the left, notice the large areas of red, that is, tree removal, driven largely by the linear stormwater management facilities shown in bright blue on both sides of Braddock Road. On the right, these particular SWM facilities have been consolidated elsewhere on the project, and retaining walls have been added on both sides of Braddock Road to maximize tree preservation, shown by the increase in green area. Slide, please. Adding the retaining walls described on the preceding slides comes with a significant cost. Phase 1, east of Southampton Drive, includes 2,100 linear feet of walls with an estimated cost of $2.6 to $5.3 million. The substantial variation in cost is because the type of wall has not yet been determined. In order to preserve the maximum number of trees, more costly construction methods will be required at certain locations, likely including some of the wall types discussed earlier. Phase 2, west of Southampton Drive, includes 2,000 linear feet of walls with an estimated cost of $2.5 to $4.9 million. Thus, the total cost impact on the project is anticipated to be between $5.1 and $10 million. Slide, please. Complex projects such as this one, every design decision carries multidisciplinary impacts. This SWM strategy presented during our previous public information meeting on November 29, 2022, relied primarily on linear facilities largely within existing VDOT right-of-way. However, 8 of the 21 facilities would have required more right-of-way acquisition, a total of 1.9 acres, and more removal of trees than the revised strategy. The revised strategy presented at this time preserves more trees and requires fewer but larger stormwater management facilities, some of which require additional right-of-way acquisition. Proposed acquisition includes 0.1 acres from St. Stephen's United Methodist Church adjacent to Braddock Road, but without any impacts on the church's built infrastructure, 0.42 acres from Dunley Homeowners Association public space, but not from individual property owners, 0.21 acres from an undeveloped parcel between Red Fox Drive and Woodland Way, and 0.13 acres from the Catholic Diocese of Arlington, Virginia, that is, from Holy Spirit Catholic Church. The net savings achieved by the revised stormwater management strategy are 1 acre of right-of-way acquisition and numerous trees. Following the old strategy, 44% of right-of-way acquisition was for stormwater management. Following the revised strategy, just 30% of right-of-way acquisition is for stormwater management, an improvement of 32%. Slide, please. Another design feature which we wanted to follow up on is the potential pedestrian bridge over Braddock Road just west of Burke Lake Road. We conducted a voluntary poll during our presentation as part of Public Information Meeting number 2 on November 29, 2022, the results of which split almost evenly between support for removing or retaining the bridge. We also gathered comments through the project website. If you have not yet had a chance to do so, we suggest that you visit the project website and specifically the public outreach summary for further details. Based on the feedback we have received from the public and from our elected officials, the pedestrian bridge has been removed from the design. Please note that the current design does not have any features, such as stormwater management facilities, that would preclude construction of a pedestrian bridge at this location in the future should the need arise. We also anticipate that removal of this bridge from the project will offset the overall cost of adding the retaining walls described previously. Slide, please. We also want to share some recent updates to the project design along Ravensworth Road. Based on consultations with representatives of Ravensworth Baptist Church, and after additional traffic modeling, we have extended the southbound right turn lane by approximately 200 feet approaching Braddock Road. Modeling indicates that this will be sufficient to prevent the queue from backing up past Kalorama Road during peak hours. Note the section labeled AA just north of the Braddock Road intersection, that is just to the right. This will be discussed in more detail in just a minute. Slide, please. Consultation with the county's active transportation staff, we have also revised the typical section along Ravensworth Road to extend the shared use path north from Ravensworth Baptist Church all the way to Heritage Drive. This is consistent with the county's comprehensive plan and will provide a contiguous facility from the path along Braddock Road. Bicycle traffic will be shifted from the on-street bike lanes onto the path up to Heritage Drive. A 7-foot wide buffer strip will also be provided between the back of curb and the inside edge of the shared use path. Utility poles will be placed within this buffer strip, eliminating the need for an additional easement outside of VDOT's right-of-way. From Kalorama Road north to Heritage Drive, this typical section can be accommodated entirely within existing VDOT right-of-way. The 4-lane section illustrated here will be provided only from Braddock Road up to the beginning of the southbound right turn lane. North of Kalorama Road, the 2 northbound lanes will merge into one, and then a left turn lane will be developed for Heritage Drive. Of Heritage Drive, the roadway will transition back to the existing section with 1 vehicular lane and 1 bicycle lane in each direction. Turn the presentation over to my colleague, Suresh Kare, to go over some details on how we evaluated the various options in order to arrive at the preferred option.
Thank you, Phil. During our second public information meeting held on November 29, 2022, we discussed public input survey results, the evaluation scoring summary for different options, and a staff recommended option for each of the 3 critical intersections shown on this graphic. During and after the meeting, we received multiple questions regarding additional details on the evaluation methodology and the details involved in the evaluation scoring. To address these questions and provide a better explanation of the evaluation methodology, the project team prepared a comprehensive Braddock Road Multimodal Improvements Frequently Asked Questions with responses. These FAQs have been posted to the project website. Next slide, please. This evening, I would like to walk you through our evaluation methodology along with a specific example of one of the critical intersections. As you may recall, the original Fairfax County study included a comprehensive evaluation of multiple improvement alternatives for Braddock Road and compared those alternatives based on specific measures of effectiveness, or called MOEs, and scoring. Those MOEs and scoring were developed based on extensive coordination and input from the Citizen Advisory Group, also known as the Task Force, consisting of a number of community members and representatives. For the current project, we use the same evaluation methodology as a guide and made additional refinements to address the need for intersection-specific evaluations. We used 6 evaluation criteria, with most of the criteria having several MOEs within them. Each criteria was assigned a relative weight, with the weights of all criteria combined adding up to 100. Next slide, please. Here we have the specific evaluation criteria along with the relative weights and the various associated MOEs. Consistent with the original study methodology, multimodal safety received the highest weight. One of the refinements we have incorporated into this evaluation methodology is to explicitly add a category to capture community impacts, which included the community survey of the proposed options. Each of the MOEs, such as intersection delay, travel times, area of impacted land, etc., were evaluated on a simple rating scale ranging from -2 to +2. No build conditions were considered to be the baseline and were assigned a score of 0. Therefore, an option that performed best compared to the no build condition received the highest score of +2, and the worst performing option received a score of -2. The various MOE ratings under each criteria were then averaged and multiplied by the weighting factor to establish the score for that criteria. Scores of all evaluation criteria were then aggregated to derive the total score of the option. I understand it may sound complex, but I will walk you through this methodology using one of our critical intersections as an example to provide you with a better sense of how this is a comprehensive evaluation that accounts for each of the evaluation criteria. Next slide, please. Let's look at the Braddock Road and Danbury Forest Drive, Wakefield Chapel Road intersection results based on the application of the evaluation methodology described on the previous slide. To recap briefly, we considered 3 improvement options for this location. The base option is a partial R-cut, also known as a restricted crossing U-turn. Option 1 is a traditional 4-legged intersection, and option 2 is a paved traffic signal combination. Schematics of these 3 options are shown on the right side. During our November 29, 2022 public information meeting, we shared the final score for each of the options and identified the base option as the staff recommended option based on the highest score. On the left is an expanded table showing the individual scoring of each of the 6 evaluation criteria and their corresponding scores. As you can see from this table, operations, right-of-way, and environmental impacts elevated the base option. One of the common questions we received was, why is option 1 not the recommended option at this location when the survey results favored option 1? The table shows that indeed the community impact score was highest for option 1 and the base option had the lowest score. However, when combined with all the other criteria scores, the final score was highest for the base option. And now I will turn it back over to Calvin to wrap up our presentation.
Thank you, Suresh. Anticipated project costs, funding, and schedule. As we have previously discussed, the project has been divided into 2 phases. Phase 1 is the eastern portion from Southampton Drive to Ravenworth and up Ravensworth to Heritage Drive. It is funded through construction based on the previous design concept as presented during PIM number 2. Adding the retaining walls in phase 1 is likely to increase a funding deficit, to create a funding deficit. Phase 2 is the western portion from Humphrey Drive to Southampton Drive and is not funded beyond design approval at this time. In terms of schedule, our project team will continue to advance the design through the approximately the fall of 2023 with design public hearing including 40% design plan anticipated by late 2023. After design approval, phase 1 will move forward with final design, right-of-way, acquisition, utility relocation, and construction. Note that VDOT has begun an early assessment of potential utility relocation and utility easement need, but this activity will proceed in earnest only after design approval. At this time, phase 1 acquisition is anticipated to begin in the spring of 2025 and construction of phase 1 in the fall of 2028 and is projected to take approximately 3 years. VDOT will thrive to identify and take advantage of any opportunities to accelerate right-of-way acquisition, utility relocation, and the construction of the project. Next slide, please. As you can see on the screen, there are multiple ways you can provide us feedback for this meeting. Please submit your comments by August the 7th. Next slide, please. Thank you very much. On the behalf of Fairfax County and VDOT, we want to sincerely thank you for your participation and input. We look forward to continuing to work with the community to implement this important project. Again, thank you.